In this video, we're going to be looking at our first in-class laboratory, and we're going to be going through it step by step. First thing I'm going to do is I'm going to introduce what a lab actually looks like. What is this thing that we're calling a lab that we're going to go through and execute all these commands? Well, in fact, all it is a simple text file. In fact, I can open this file. Whoops. I can open this in text editor, and you can see that all of these instructions that are in this file are just typed material. It could be a Word document, could be a text file, and so on and so forth. But all of this stuff is just text. And some of this text involves commands that R Studio is going to execute for us. Others of it are instructions or background or things that'll help you understand what's going on. And any of those are behind hashtags, behind these number signs. Anything behind a hashtag or a number sign is a comment. That it's something that R is going to ignore. It's just there for your benefit. Okay, so I'm going to open this. There's a couple of ways I can open this. One way I can open this is to go into R or R Studio. Okay, I can either start a new project or I can just open it here. Okay, let me see if I can't find the open. And I'm going to go up to the desktop. I'm going to locate my, let's see where my, nope. Here we go. I'm going to locate our third exercise here. This is the first lab exercise that we started in class. I'm going to open that, and now it's loaded into this window. Another way that I could have done that is that if it has the .r postscript on it, it will open RStudio automatically if I double click on it. So I've just done it again. It's probably two copies. Might be two copies of it that I'm using right now, but you can open it that way as well. Okay, so let's go through this code that we're going to be working with. Okay, remember this is going to be where our code window is, and this is where our output is down at the bottom there. Okay, this is the coding window. This is our console or our output window. Okay, so you can read through these hashtags, but the first thing we want to do is execute this command rm remove list all these different variables that might be hanging around here for some previous program. So you can click into that, or you can highlight it and hit run. And it will echo that it executed that command at the bottom and give you a new prompt at the bottom. Okay, again, I'm going to bring this up a little bit just to make sure you can see the bottom of this thing. Okay, good. That makes it a little bit smaller, but you'll be able to at least we'll be able to see that for sure. Make sure we don't get cut off at the bottom. Make it a little bit bigger. Okay, so next, there are several packages that have commands and files, for instance, that I'm going to need to be able to execute all of the exercises that are here. Okay, and the way I'm going to get to those is I'm going to say install all of these packages. So I could click in here and say run, and it installs that package for me. Now notice it jumped to the next line. I can tell it now run and install that package. It did that also, taking a little bit longer, and then it's done. And then if I want, I could just do these all together, highlight them both, and it will install these last two packages for us. There are various commands, various things in here that we're going to need for this particular exercise. Now, again, you could go into packages as we did before, and you can find these on here, and you'll see that they're present, but they're not checked off yet. So in order to use these packages, you have to tell it that you want to make them available in this particular program. And for that, you use the library commands. I'm going to highlight all four of them. And I'm going to say click run. And now if you were to go back in here and take a look in here, you'd see they're present and they're checked off as available for your program now. Okay, so the first thing I want to work with is a file called Arbuthnot. Arbuthnot is a collection of data by a minister in the 17th century. He kept track of the number of births of boys and girls in this community, I guess in Great Britain somewhere. Well, I guess it was in Great Britain at that time, right? So anyway, this is a file that we're going to be working with. So if I just click in here and hit run, it shows me the first 10 or so rows of data and in the columns, the variables. So this is not all of the data. This is only the first, gives us just a quick look at this data. It does tell us there's 72 more rows of data, 72 more years of data here. So the next thing I might want to use is maybe there's another command I can use to get another view of what this data set looks like. And in fact, there's a command called glimpse. If we hadn't loaded those packages, this would not work. So I'm going to click in here. I'm going to say run that command. And now we get the same kind of information, a little bit formatted a little bit differently. Tells us 82 rows. There's 3 columns, year, boys, girls. And we can see these numbers in sequence here from the first year to the last year. First year was 1629, 1630, 1631. So that's what we see now. So our first data, we've learned basically how to load packages and make them available using a library command, and how to view a file. We didn't have to load this. It was present for us. It was already present for us, loaded with one of these packages. Now that we know how to do that, now we can start with some exercises, learning something about this. Okay, so learning how to use, learning about the data that we're looking at, and also learning how to use R&R Studio. So the first exercise that we have is, well, gee, we know how many, we got a glimpse of this data. What if we want to adjust what the number of boys is? Well, we can tell it, show us Arbuthnot, but show us only the variable boys. $sign tells us the variable that you want to work with. So that's the only change there. Hit run, and now we only have the data for boys. We have the full data set this time now when we did that. So obviously, what's the way to good way for us to see our first exercise? A good way for us to see just the data for girls. Just change that variable to girls. Again, a situation where we're using the same command, we could cut and paste, just change the part of it that we need. Hit run, and now we see the data for girls. So now let's take advantage of a little bit more capability that we're given in R when we added that package called ggplot. Remember that one of those packages was called ggplot. And that's going to allow us to display the data on a graph. Okay, so ggplot, we use the command ggplot. We tell it, this is the format this has to be in. We tell it the name of the file. We tell it that we want a graphic. That stands for aesthetic. We want a graphic plot. We want X to be the Y, X-axis to be the year, and the Y-axis to be the number of girls born that year. And we want it to be geometric points. We want it to actually be represented by points in that plot. Anything after the hashtag is just extra information helping you. It's not anything that R is using. So I'm going to click run, and I'm going to say, where's my graph? And sure enough, it switches over to plots, and there is my plot of the number of girls born each year in the year 16, I guess 29 through 17 something. Okay, I can click on this to zoom it out so I can see the window a little bit better, print it out, export it, so on. Okay, so what can I do next? Well, maybe I didn't want dots. Maybe I wanted lines. So now we've only changed one thing between these two, and now we've changed it from geometric point to geometric line. I'm going to click in there, hit run, and bingo, there is our display as a line instead. Okay, what if I want both points and lines? Well, then I just geometric points plus geometric lines. I hit run, I click in anywhere I want, and it connects them and draws a line for me as well. So that's pretty cool, right? We learned how to do some graphics now. Okay, so now what's my next exercise? My next exercise is going to be to assess trends. Okay, so we can use, one of the ways that we can do this is, let's say we wanted a total of boys and girls for each year or for a particular year. I can use R as a calculator. I guess there's one particular set of data that might be 512 boys, 462 girls. We can hit run, and it'll do that calculation for us. If we wanted to do it for the entire data set now, we would use Arbuthnot, identify the variable, and Arbuthnot, identify the girls, and add together those two variables. Click run, and there we go. There's our output, which shows us the sum of all of these. Actually, you can see that first date. That was just copied from our first year, 1629. So you can see for each individual year. So the strength of this is that you can do this kind of calculation very quickly, very easily. Now we're going to introduce a new twist. Okay, and that is, let's say we want to change the data set. We want to add a new variable to the data set. Maybe that total is interesting to us, so we don't want it just in the console. We want it added to our data set. So the way that we do that is we say, let's take our file arbithnot, let's run it through a process. That symbolizes you're gonna run the data set through a process. That process is going to be the command mutate. Mutate means change it. We're going to create a new variable. I'm either going to change a variable, create a new variable. Well, I'm going to create a new variable called total, and it's going to equal to the variable named girls plus a variable named boys to create a new variable. So I'm going to click in there. I'm going to say run, and it executes it. All you see is that you can get an error that it executes it. Okay. Notice that where did it put that new variable? Where is that new data set? It put it into the original data set. So now arbithnot, the way we started, doesn't exist anymore. Now the arbithnot is a different file with a fourth variable in it. That's good. If you didn't wanted to keep the original file, you could have put it into a new file, called it arbithnot2 or something like that, and preserved the original data file if you want. Sometimes that's good practice, right? So in other words, let's say, hang on a second here. Let's see what we actually have here. I'm going to just do this as a side here. I just pasted that in there. I click run. And sure enough, look, there's 4 variables now: years, boys, girls, and total. So that actually worked. It worked. Okay, so now let's create a new plot that has year versus total, okay, on the X and Y axis. I'm going to click run. And there's our new plot. Look, very similar to the other one, because you would expect it to be very similar, right? So anyway, what's the boy-girl ratio? I'm going to take the first year, 1629, and do it mathematically. There were 5,218 boys and 4,683 girls. So what's the ratio of boys to girls? Well, ratio turns out to be 1.1, 11% more boys born than girls born in that year. Okay, so as you can imagine, okay, well, what's the percentage of boys that were born? Well, this is the total number of boys and girls born, and this is the number of boys that were born. So if I run this, it's going to be the percentage of boys as out of the total. So that's going to be 52%, right? So we got another way to look at that. So now let's plot. Let's take arbithnot, that file. Let's run it through a process where we're going to add a new variable, mutate, we're going to add a new variable, and it's going to be the boys ratio. And it's going to be the number of boys over the total. Remember, first year was 52%. So I'm going to click in there, say run. It's going to execute it. Again, you don't know it. See, it's going to put it into the same file. You don't know the result of that until you take a look for it. And there it is. There's a percent. That's a new variable, has a percentage of boys to the total, right? And for each individual year. Okay, so now another way you could look at this is as to graph it for you. So we're going to take, arbithnot. So yeah, we're not going to graph it yet. I got ahead of myself. Okay, next thing I might want to know is, how many years are there more boys than girls? Okay, well, that's kind of a logical operator, right? Yes or no? Are there more boys than girls? Yes or no? So that's a logical operator. Maybe we can do that here too. Let's take that arbithnot. Let's run it through a process. We're going to mutate it, make a new variable. It's going to be called more boys. And more boys is going to be equal to when boys are greater than girls. There's more boys than the number of boys in boys is greater than the number of girls. So I'm going to click that. I'm going to hit run, and it executed it. We don't see it yet, but now we can ask it to show us that variable that we just put into our original file now. I'm going to show us that variable. I'm going to click in here, and it's going to show me when there's more boys than girls. And look, it's for every year. That's true. There are more boys than girls born every year in this. Well, let's plot the year versus the boy to girl ratio. I'm going to hit run. And here we are. Look, some years it was a lot, some it was a little. It's kind of a scatter plot here, right? So And it doesn't look like a particular trend here, but one thing we can see is that every year, whoops, I meant zoom. Every year, every year it's been above 50%. Even though it's kind of random, it's always above 50%. It's always every year for 75 years or whatever it is. It's almost 100 years. Every year, there's been more boys born than girls born. I wonder if that holds up today, whether or not that's true today or not. Okay, so at any rate, so, okay, I may have to. Okay, so next, how? Let's see if we can find out the maximum and minimum number of boys born each year. So again, we're going to run through a process. This process is going to be called summarize, and it's going to ask us what's the minimum number of boys, right? Create a variable minimum and minimum number of boys, another variable maximum number of boys. Let's execute that. And it displays for us that the minimum number of boys that were born in any particular year was equal to 2890, and the maximum number was 8426. Okay, so now that's exercise 1, 2, 3. Exercise 4, 5, and 6 are a separate file. And we're going to pick up separately for that in the next video. However, I'm going to introduce it to you right now. Okay, I'm not going to bother to save this. Okay, so what does that exercise look like? I'm going to open it. This is really extended exercises. I'm going to open it with text edit so you can read it. And what does this tell us? What is this exercise? Okay, well, it asks you, notice it tells you which packages to install. And it tells you that, oh, this is more exercises. This is where 4, 5, and 6 are. What do they want to do in 4, 5, and 6? Well, we want to answer the question. What years are included in this data set? It's different data set, though, data called present, right? So you're going to do everything you did with Arbuthnot, except not everything. You're going to, instead of using Arbuthnot as the name of the file, you're going to use present as the name of the file. Okay, what years are included in this data set? How do these counts compare to Arbuthnot's? Are they similar? Are they different? And so on. Okay, and that's, again, this is data that brings us up to the present. Now it asks you make a plot that displays the proportion of girls that are born over time. We saw how to create a plot. With Arbuthnot, we're going to use the same kind of code, except we're going to substitute the file name present and the variable names that are appropriate. So finally, it says which year had the most births. And you could see, remember we did that minimum and maximum with Arbuthnot? You can see you can kind of do the same thing. So the deal here is that some of this is going to be, I think the last 2 or 3 questions in quiz 1 require you to do calculations on the data set that will give you this information. So you might have to run a couple, you might have to do this to finish quiz 1 successfully. So basically, you're supposed to be on your own with this, but I'm going to create another data set, or at least give you the coding that you can use and execute on your own to do this. But I'm going to wait a day or 2 before I do that to incentivize you to give this a try on your own. But I'm not going to leave you hanging. Within a day or 2 of posting this video, I'm going to add another video. I will give you the coding as a file, and I'll also add another video of me running through it as well, in case you want to wait for that. Okay, so thanks for listening through this 3rd video.